we're going to do number 146, the LRU cache. So we're going to design a data structure that follows the constraints of a least recently used cache. Implement the LRU cache class. So the LRU cache receives a capacity. Initialize the LRU cache with a positive size capacity. And then the get function will return the value of the key if the key exists. Otherwise, it will return -1. The put function will receive a key and a value. It will update the value of the key if the key exists. Otherwise, key value it'll add the key value paired to the cache. And then if the number exceeds the capacity of this operation, it will get rid of the least recently used key. Functions get, put, and must run in O of 1 average time complexity, which is quick. So example 1, we've got all these puts and gets, and it will either return null, -1, or it will have the key of that piece. So let's go ahead. Well, the constraints are from 1 to 3000 for the capacity, from 0 to 10 to the 4th for the key, 0 from 10 to the 5th for the value, and then at most 2 times 10 to the 5th calls will be made to get and put. A little bit of a stress test. So for here, we're going to initialize a capacity, just a constructor here. So we'll do self.capacity, since that's put in, equals capacity. Oops, this is not JavaScript. And then self, and initialize a cache. Store all these pieces. So self.cache equals a new cache. So the get function, what we want to do is we want to check the keys in cache and then pop it off the end, put it back at the beginning, to do an O of 1 operation on these lists. So if the key is in the self.cache, then what we'll do is we will set the value equal to the value that is in the cache from the key, and then move forward with setting self.cache key equal to the value. So that just pops at the end, pops back on the beginning, and then we'll return that value. Otherwise, we're just going to return -1 because that is not satisfying to our needs. For the put function, what we need to do is update the value of the key if the key exists. Otherwise, add the key value paired to the cache, or if it exceeds capacity, take it off. So we got 3 things that we might be doing. So the first one, let's check if the key is in the cache. So if key is in self.cache, then self.cache.pop key. Otherwise, if the length of the self.cache is greater than or equal to the capacity, then what we're going to do is just pop it off the end. Self.cache.pop the next. We'll iterate of the self.cache. And then if those are not satisfied, we are going to set the cache key equal to the value. And that should be it. satisfies all the things they're asking for, and get put or O of 1 for each one of those. So we'll run it. Looks like there's a, oh, forgot T. Run it again. Looks like that worked great, and then we'll submit it. Got a lot of stress tests, so perfect. Looks like it does pretty well with runtime. Like you said, everything's O one time, or else it wouldn't have accepted it. So there's that.